Good evening, sir. Myself in Reddy Sai. I will deal with the physics subject. In that physics subject, I am dealing now electronics. In this electronics, the present topic is learn PN junction diode. And PN junction diode is a two-terminal device which is formed by using a P-type material and the N-type material. So before going to this, we should know the types of solids or materials. We know that these are classified into three types. Those are silicon, those are conductors, semiconductors, and I'm writing the first letter of the words, that means conductors, semiconductors, and insulators. And these conductors having the energy band gap of approximately 0 electron volts between the valency band and the conduction band. This one is the valency band and this one is the conduction band. So there is a gap between this valency band and conduction band. This band gap called as energy band gap. For a conductors, it is approximately 0 electron volts. For semiconductors, it is lying between 0 to 3 electron volt. Okay. For insulators, it is greater than 3 electron volt. So based upon the energy gap between the conduction band and insulators, we can define the material into three categories. Those categories are developed by using the energy band gap of solids. So for creating a PN junction diode, we need a semiconductor. We need a material called as semiconductor. So for semiconductors, where it is the slider, yeah, for a semiconductor, here we are showing the silicon material. Here is the silicon material which is having a outermost orbit of 4 electrons. Here is that 4 electrons, and these electrons are free when compared to the first orbit and second orbit. This one is the first orbit and this one is the second orbit. In the first and second orbits, the electrons are tightly bounded to the atom, but compared to this outermost orbit, these electrons are not that much of tighted and it is free. So whenever the silicon is added with the pentavalent atom means the outermost orbit which is having the 5 electrons, and these valent electrons or pentavalency outermost electrons are combined with the silicon. I am writing here the silicon electrons as sky blue color, C, and the phosphorus electrons are considered as here orange. Whenever this silicon is combined or added with the or this silicon, whenever there is a pure silicon and we are adding the phosphorus inside the silicon, then the 4 electrons of phosphorus and silicon are formed a covalent bond, and one extra electron which is present in the phosphorus are free from the bonding nature. So for that reason, if you are adding more electrons to the phosphorus, you can create a number of free electrons in the material. Those material we called as a n-type material. N-type material. Okay. So if you want to create a p-type material, we should dope the silicon with boron. Boron. You are seeing here the boron, where this boron outermost orbit having only 3 electrons. So these three electrons are combined with the silicon. I am writing here, okay, and the outermost orbits here I am mentioning in the form of black color as electrons, and yellow for the boron electrons. Okay, so whenever these boron electrons are combined with the silicon, there is a empty valent which is unfilled to the silicon atom. Those one here, see here create a bond which is empty, so which is empty, this one called as hole, this one called as holes. If you are adding more number of borons into a silicon atom, you will create a p-type material, you will create a p-type material, this one. So by combining the p-type and n-type materials, you can create a p-n junction diode which is having a number of holes number of holes more in the p-type, and number of electrons in n-type is more. Okay, p-type is having more number of holes, majority carriers are holes, and n-type having the majority carriers as electrons. So these are the present elements in the p-type and n-type materials. Whenever you are adding these two materials, then it will create a diode, and at that time, due to the internal temperature and the combining effect of the diodes, there will be a creation of depletion region which is having the electrons and holes which are present in n-type and p-type are formed here and create a potential difference. I am explaining briefly about all those things because of it will take too much of time. So it will create a potential difference between the two materials, and these potential difference called as a potential barrier in the p-n junction diode. So this is more depend upon the doping concentration. If you are considering a xeno diode which is highly doped with the p type and n type, then the potential barrier will be more. So the symbolic representation of p-n junction diode is this one. Here is a anode and here is cathode. I think here the word is missing, anode, and this one is cathode. So by adding extra power source to the p-n junction diode, if we are adding a plus for the p and minus for the n, then the diode is in forward bias. Okay, then the diode is in forward bias. If you are adding negative terminal for the p type and positive terminal for the n type, then the bias will be reversed, this one is minus and this one is plus. Then this type of connections called as negative biasing, that means reverse biasing. Okay, the n type is attracted with the p and p type is attracted with the n, then there is a increase in the depletion region takes place, there is a increase in depletion region. So for that, no two electrons or no two holes which are present in the n type and p type is not possible to move from n to p. because of the increasing in depletion region. Here the width is increases, so we can't transfer the n type material into the p type material, but in practically we are getting a microamps of current. Okay, so in the next slide there is a IV characteristics between the forward biasing and reverse biasing. So whenever you are connecting the elements in forward bias, that means here P is connected with plus and N is connected with minus, you will get the characteristics as like this. The graph is showing as V is increases, then V is increases, then I is also increases. So similarly for the negative connection, that means if you are connecting P with minus and N with plus, then you are getting the reverse bias graph here. So whatever may be the connections are given in a reverse bias, but there is a difference between the forward current and the reverse current. If we are further increasing the voltage here, see this is the cutoff voltage. So actually here what is happening means it is not moving as I is increases, as V is increases, then I is not is also increases in the forward bias, but in the reverse bias the I is not increases, it will be slightly cut off at the Vz. Okay, this is the one of the drawback in the PN junction diode, but these drawback or this is the one of the good quality for the G node diode. Why means because of whenever there is a excess of voltage is occur, it will cut off the range and make the devices safe. So these all about the PN junction diode.